Tonight, though, we're here to learn more about electric vehicles, and we have two experts we're welcoming. Rosemary Mascali is the co-chair of the U.S. Green Building Council Long Island Sustainable Transportation Committee and chair of the Drive Electric Long Island Education and Outreach Committee. And joining Rosemary, Nick Palumbo is the executive director of sustainability programs at Suffolk Community College. So please join me in welcoming Rosemary and Nick. Take it away, guys.
Hi, thank you for that introduction. The U.S. Green Building Council seeks to transform how buildings are designed, constructed, and operated through its LEED building rating system. And part of that rating system includes transportation, and that's how we're involved with the U.S. Green Building Council promoting electric vehicles. Today's program is the Drive Electric Long Island Coalition is a group of EV stakeholders, people interested in promoting electric vehicles, and we work together to encourage the adoption of electric vehicles as well as more charging infrastructure on Long Island. As Jeff mentioned, this is part of the Transportation Innovation Series that have been Tuesday evenings. The Transit Solutions Bingo was on January 12th. It was a very successful program. Today, we're doing the Electric Vehicles 101. And as Jeff mentioned, on March 9th is coming up the Let's Walk Port Washington, hosted by Residents Forward. And Jeff went through that. These are some of the signs that will be starting to see in Port Washington, telling you how many minutes it takes to get some locations. That's a really exciting program that we're from the Sustainable Transportation Committee interested in promoting around other parts of Long Island. So that'll be a great program too. So our program today is promoting electric vehicles, and our speaker will be Nick Palumbo. Nick is the executive director of for sustainability programs at Suffolk County Community College. Nick, in his role, he works to bring environmental awareness to all aspects of the college's mission. Nick's a member of the Drive Electric Long Island, as well as the Sustainable Transportation Committee for the U.S. Green Building Council and the Sustainability Committee for the town of Southampton, where he lives. Nick is a former U.S. Navy officer and holds a bachelor's degree in mechanical engineering from Villanova University and a master's degree from NYIT in energy management. And he's been driving a hybrid, plug-in hybrid, and battery electric vehicles since 2002 and is a proud owner of a Tesla Model 3. So Nick, I'll stop sharing and you can take it away.
Great. Thanks, Jeff and Rosemary. Hello, everyone. Good evening. So I was asked to do this presentation tonight. I've done this presentation a number of times. I've modified it over time and it's evolved, but I want to start by making a little bit of a confession, and that is that I'm a big-time electric vehicle enthusiast. I guess that makes sense, given that I'm doing this presentation. But I've come by it honestly. Like Rosemary said, I've been driving a hybrid or an electric vehicle now since 2002. I've done a lot of research on the industry. In my line of work in sustainability, I recognize the importance of electric vehicles for the environment, and all the things that I'm going to talk about as part of the presentation. But I wanted to be upfront at least and share that I'm coming at this from somewhat of a biased perspective. I'll try and be objective in the Q&A period, but I'm very much here tonight trying to sell all of you at least on the idea of an electric vehicle as your next vehicle purchase. And so I'm going to share my screen now and bring the presentation up. So this presentation, like I said, I've done this a few times now. And I like to start with something that kind of explains that. I think so. This is a car ad that was put out by Nissan for their Nissan electric Leaf, and I think it kind of gets to that idea a little bit of why. So I understand, like I said, I'm a big EV enthusiast, but not everybody is at this point. Not everybody maybe is aware of the benefits, and I think it's natural to be apprehensive about a big technological change, which an electric vehicle is, and vehicles are very personal, and so I think this ad from Nissan kind of touches on the idea of really kind of rethinking, or at least giving yourself an opportunity to rethink what vehicles can be. So let's start with the Nissan ad.
What if everything ran on gas? Then again, what if everything didn't? The 100% electric, zero gas Nissan Leaf. Innovation for the planet, innovation for all.
So I really like that ad. It still makes me laugh every time I see it. But anyway, so yeah, there's a number of reasons that I'm going to talk about on why I think that you should consider an electric vehicle. And first and foremost, and this is an important one for me personally, and everyone's motivations are different, but there is a big environmental benefit to electric vehicles. And so this graphic here shows you, I'm sure you've seen these badges on a lot of different cars. It shows you the relative environmental impact of different categories of vehicles. And so this, even within the low electric, the low emissions vehicle categories, there's a wide range, starting at the left, the low emission vehicles, and then all the way up to zero emission vehicles, which are fully battery electric vehicles. And so I think this is something, like I said, that a lot of people have seen and not really understood what these different categories represent. And so this graphic talks about that a little bit. Another consideration when people are buying vehicles, which is obviously very important, is what's the economic bottom line for the purchase? And here too, I think there's a clear advantage on electric vehicles, and I think that this is an advantage that's only going to continue to build as the cost of the technology comes down. And so, I mean, fuel costs obviously is one element of that, of your transportation budget. And so obviously, gas prices fluctuate rather drastically depending on what's happening in the world, and something that we've seen. I know, even in recent years, this has been something that's changed a lot. And I mean, to be honest, gasoline prices are relatively low right now, I think, certainly in comparison to what they have been. But still, that's something that can change at any moment. And another factor, obviously, is time. And one real big advantage, I think, for all of us who live here on Long Island is that electric vehicles and even hybrid electric vehicles are eligible for the New York State Clean Pass, which allows you to travel in the HOV lane on the expressway. And that's a major time saver. I don't even commute on the LIE, but I know I've certainly taken advantage of that on numerous occasions. And then, so sticking with the economic advantage of EVs, this is something, again, this graphic is relatively recent, but these numbers fluctuate quite a bit. So there are a lot of incentives available right now at both the federal and state levels. New York, you can see there has a $2,000 rebate for new electric vehicles under 60,000, $500 rebate for vehicles over 60,000. And then at the federal level, there's a $7,500 tax credit, which is capped by manufacturer based on number of vehicles sold. So that is available to certain manufacturers, and others have kind of run through that limitation. But I think right now it's fairly evident that the new administration in the White House is very supportive of renewable energy technologies and electric vehicles, and I would expect that those types of incentives are going to continue to be available. It's just a closer look at those at the state and federal level. And then another consideration, I think, is energy security. And this is something, that obviously influences our geopolitical environment, the availability of the fuel supply that we use for transportation. You can see here that a third of the US petroleum is imported and 75% of that goes towards transportation. And obviously there are impacts related to that. And then this is an important one that I think is really overlooked by a lot of people, and that is, as Rosemary mentioned, I'm a mechanical engineer. This is something that I'm very aware of, and having owned a battery electric vehicle now for almost 4 years, it's just the relative complexity of an internal combustion traditional gasoline engine vehicle versus what I'm driving now, a battery electric vehicle, and what that translates to in terms of operating costs, certainly, but maintenance costs. And so I put together a list of some of the elements and systems that exist in an ICV or internal combustion vehicle that don't exist in its equivalent battery electric vehicle. So transmission, carburetor, fuel injector, everything you see here, those systems don't exist in a battery electric vehicle. They're not needed, and obviously therefore are not subject to wear and tear, breakdown, and replacement costs. And the other side of that is that fully battery electric vehicles also have inherent as part of their operation 2 features which really reduce wear and tear on other vehicle components. So I'm not sure if everyone's familiar with the idea of regenerative braking, but essentially on an electric vehicle, the electric motor itself can serve as a braking system. So when you're not accelerating, the car will begin to decelerate by converting the kinetic energy, the movement of the car, into electricity. By spinning the electric motor backwards, it actually becomes a generator and creates electricity, which is then channeled to the battery. And so you're using the rolling motion of the car to create its own energy. And so that's advantageous from a fuel efficiency standpoint, but it also reduces the wear on your brakes because it becomes your primary braking mechanism. And really the hydraulic disc brakes on most electric vehicles are much smaller, and they're subject to replacement much less frequently because of the regenerative braking capability that the car has. And also idle stop. So idle stop is a feature where when an electric vehicle is stopped at a stop sign or at a red light, the propulsion system for the car basically becomes inert. So you don't need to run your power plant when you're stopped. Basically, the car shuts off. And then when you go to accelerate, when the light turns green, then your propulsion system comes back alive. And so what that means is that you're utilizing all of those systems a lot less often than you would be in a normal internal combustion vehicle. So the other advantage in my mind that, this is an important consideration for some people, is the high performance capabilities that an electric vehicle is capable of. And, this is one of those things that's somewhat hard to describe until you drive one. But I did find a video clip from YouTube. I actually saw this originally, there we go, on Jay Leno's show. And let's start that here a little further. Whoop. I'll do that.
Car I'm driving right now.
Skip some of this.
2008 Roadster. This is a very.
So Jay spent the day with a lead designer from Tesla, and his last segment here, he gets to drive in their new Tesla Roadster. And some of you may know Jay Leno is a big car enthusiast, and his reaction here, I think, tells a lot about the performance capabilities of the Tesla Roadster.
All right, 600 miles on a car I'm driving right now is the
Back to that.
car I'm driving right now is the 2008 Roadster. This is the very first model Tesla ever produced.
Sorry. Right, this is giving me trouble.
Car I'm driving right now is the 2008
Well, we could skip over
Roadster.
that. In any event, it's worth a look if you're interested to go on YouTube and watch Jay Leno driving the new Tesla Roadster. It's a pretty amazing car, and Jay's white hair blows back pretty dramatically. So I put this in there to calm everybody down after the excitement of Jay Leno, but we could skip over it now. And so I think the question becomes, like a lot of things, timing is important, and a lot of people ask me, why now? Is this a good time to buy a battery electric vehicle? And my response to that is yes. And I think the advantages that I talked about a little bit are going to continue to become more and more pronounced. And I think you've probably seen news stories that would indicate that most of the major automotive manufacturers are starting to recognize that and have made commitments to transition their fleets to electric vehicles in the near future. And I think there are some really compelling reasons for that, and we'll talk a little bit about some of those. The major one that's really driving transformation right now is new battery chemistries that are available in the industry, and that has sort of grown out of the electronics industry. Laptops to cell phones all run on lithium-ion batteries, and that battery technology has come down significantly in cost. The performance of the batteries has increased significantly over the last decade or so, and all of that makes a battery electric vehicle that much better and less expensive. And so that in turn has, as I mentioned, increased the adoption of battery electric vehicle technology by major auto manufacturers. And the result of that is that there's a much greater availability of different vehicle offerings in the marketplace. And not one vehicle meets everyone's needs. That's why there's numerous models available. And so I think that, as you see more and more manufacturers and more types of vehicles come into the marketplace, it's going to become a better option for more people. And then also infrastructure development. Again, this is being driven by decisions made by our elected officials because it is an important element of our effort to mitigate climate change. And so one of the ways that the government can encourage vehicle adoption is by encouraging infrastructure development, which supports charging of those vehicles. And as an EV driver, I'm certainly aware of that. I mean, I see all the time new electric vehicle charging stations coming online. I'm not sure if I wasn't driving the vehicle, if I would be as aware of it, but I can tell you that it really, the curve there of charging infrastructure availability has really started to take off dramatically in the last few years. And and on the other side, the costs of the existing technology, and that we talked a little bit about, fuel costs themselves for the drivers. They're relatively low now, but it's certainly a volatile commodity, and those costs, I think, most likely will increase as that industry starts to feel the pressure of the transition. That a lot of fuel sources are going offline, and that's going to mean an increase in cost. And then, of course, there is an environmental cost to the burning of fossil fuels, which most people accept is scientifically demonstrated and real. And that's something that has to be taken into account. And so along with the adoption of electric vehicles, I think there's definitely a shift in our electric supply, that renewable energy from solar and offshore wind is also becoming more cost competitive with traditional fossil fuel electric sources. And so there's a kind of dual advantage in making this shift. So a little further on, we're going to talk about some of the environmental benefits of electric vehicles themselves. But it's important to consider that as solar and wind and other renewable energy sources begin to assume a larger percentage of our electrical generation portfolio, that advantage becomes even clearer. Did I skip something there? Perhaps my slideshow is a little bit off here. Anyway, so here's a breakdown. This particular graphic was put together by Rosemary and the team at Drive Electric Long Island. I believe this is reflective of just Suffolk County data from 2020. And it shows you the number of electric vehicles on the road. And then the pie chart looks at the breakdown of PHEV, which is plug-in hybrid electric vehicles versus battery electric vehicles. And if you look at the trend over the last several years, there's been a big uptick in the total number of electric vehicles on the road, and the percentage of battery electric vehicles continues to expand in that pie chart. And here's a different look at that. Oh, that's really what I was just describing there. So you can see it, the numbers going up. And this data I think came in August. Rosemary, shake your head if that's right. Yeah. So this is obviously 2020 was not complete at that point, and so I'm pretty sure. Who knows with the pandemic, what those totals are. I don't know if we have an update yet, but you can see that there's sort of organic growth across the different categories here for electric vehicles. This is a breakdown of electric vehicles on the road. Again, I think this is Suffolk County data showing you by manufacturer and model. Tesla is the kind of big gorilla in the room in terms of full battery electric vehicles, and really for all plugins, all EV types here. Oh, there's the chart that I was trying to get. So this graphic shows you a couple of different things. I think what I was really trying to highlight here, though, was the third column, which talks about really the environmental impact in terms of tons of CO2 related to operation of the different vehicle categories. And you can see battery electric vehicles obviously contribute the least in that category. And that's incorporating the environmental cost of the electrical generation associated with charging the battery. So even with that, and like I said, as our electrical sources transition to renewable energy, that becomes even more stark. Okay, here's just a quick rundown of the history of electric vehicles. Again, just I think trying to make the point that the technology is not necessarily new. I think it's new to a lot of us, but electric vehicles have existed really since the very early days of automobile production. It was one of those situations where early on there was this competition between the internal combustion engine and battery electric vehicles. And obviously, over the last century, really, internal combustion vehicles have predominated. But for a lot of reasons that we've talked about here, that is really starting to shift of late, and for good reason. So we'll just kind of take a quick scroll through these. 1890s. That's Thomas Edison, I believe, with an electric Model T. That's a cool looking ambulance, electric ambulance. That's the Chevy EV1 that somebody killed. There's a good documentary on that. That green Prius on the top was the first car that I owned back in 2002. The first alternative fuel vehicle, and that was a great car. Got a lot of miles out of that. And the one below that is a vehicle I also owned at a certain point, which was also a great car. And as Rosemary mentioned today, I'm driving a Tesla Model 3, which is that vehicle down there in the lower left. And having experienced that, driving an early hybrid and then a plug-in hybrid, it really, I think, prepared me for making the jump to a full battery electric vehicle. I really enjoyed the driving experience that I had with the Toyota Prius when it was in the full electric mode, but it would only operate in full electric mode at low speed, under 20 miles an hour. And so, but it kind of gave me a sense of the potential and the driving experience that I really liked. And it prepared me mentally to make the jump to the Prius, and literally the best car I've ever owned and driven. And here's just a lineup of a lot of vehicles that have been announced, some of which at this point are in production and on the road. But we're going to be seeing a lot more of these, across different manufacturers in the next couple of years. So this is a chart that's got a lot of numbers on it. I include this here to give you a sense of kind of what's out there now and how they compare. It's a little hard to absorb in looking at this very quickly, but there are quite a few vehicles available on the road already. And looking down the different categories, you can see that the tax credit is still available from some of the manufacturers. That $7,500 federal tax credit, and for others like Chevrolet and Tesla, because they've produced and sold up to the cap, the federal tax credit has expired for those manufacturers, but it may be coming back. And looking at this graphic, you can also get a sense of the kind of wide disparity in terms of range. EV range that's available from the vehicles. That's an important consideration, certainly when you're shopping for an EV. Let's talk a little bit about charging. This is a question that a lot of people have, I think, who have not owned an electric vehicle, is how do you charge it up? And I think that's something that's a bit of a it's not as big an issue, or it's not really an issue for me. And I think for most people, it really shouldn't be an issue. That, what most people are going to charge at is level 2 charging. If you own a home and you have access to an electrical source, you can charge your vehicle at home overnight. It's akin to charging your cell phone, which is something that I think all of us have grown accustomed to. And if you can do that, it really becomes a lot simpler than having to go to a gas station every so often and having to think about filling up your tank. And so the different charger types, they're rated. There's 3 primary charger types: level 1, level 2, and level 3, based on the voltage that's available at the charging source. And there's a corresponding time associated with the charger type. So a level 1 charge, which is standard household current, 120 volt current, if you're charging at that, you're going to get a very low rate of charge. On the order here, it says 5 miles of charge per hour of charging time. And so obviously that's not super convenient if you're in a hurry. Again, if you're charging overnight, that may be sufficient depending on your driving needs. But I think really what you'll want if you're charging at home is a level 2 charging setup. most battery electric vehicles will come with everything that you need. You just have to have the power supply available. So in my case, I had to have an electrician come in and install a 240 volt outlet near where I park my car in the driveway. And, once that was done, like I said, it couldn't be more simple. I charge at the end of the day if I need to. Most days I'm not using anywhere near the battery capacity, so I don't even have to do that. But I've kind of gotten into the habit of charging at night, and in the morning I have a full battery every day. So, and at a 240 volt level 2 charge, you can get between 20 and 60 miles of charging per hour. I think for my car, it's around 30. I get about 30 miles per hour of charge. And so you do a little math on that. If you're charging overnight, I mean, you can easily get 200 miles of range during that charging period. And the car, once it's plugged in, the electronics, really do all the work. It'll charge up to the capacity that it needs to, and then it'll stop charging. And then the third category, major category of electric vehicle chargers is the level 3, also known as DC fast charge. And so these are the types of systems that you have probably seen on interstate highways. There's one at the Long Island Welcome Center, exit 55, I think, on the expressway. There's a bunch of EV chargers there. You'll see them at shopping malls now more and more. The level 3 DC fast charge, oftentimes you'll have to pay for this with credit card or some other charging mechanism. But with the DC fast charge, you can charge your car very quickly, and so that's important if you're on a long road trip. I've taken a number of long road trips with my Tesla, and if you're going beyond the range limitations of the car, in my case, that's 325 miles, you're going to need to charge on the road. And so what you're going to be doing is looking for a DC fast charger. And again, like I said, these are more and more readily available really on all major roadways. And the cars, very often, the Tesla, has the capability to tell you where you need to go to charge. And usually these are set up in places where it's convenient to do so. In a rest area, you get some food, and you can get a lot of charge, between 60 and 100 miles of charge in a 20-minute stop. And so it's really a nice option for those kind of extended road trips, but it's not something that you're going to use every day. And so there's a closer look at that graphic. This here is just to give you, I don't know why I included this. I thought it was a cool looking thing. There are different charging plugs, basically. Again, kind of looking at the cell phone world as the example. There are different types of charging cables depending on what kind of cell phone you have. I mean, anyone who has an Apple, it's pretty ubiquitous. But Google has their own standard proprietary charging plug. Same thing in the world of electric vehicles. But in a similar fashion, these things are interchangeable with the use of an adapter, effectively. So you can plug one type of charging cable into any type of vehicle if you have the right adapter, which are easily obtained. This is a little closer look at the charging time and costs for typical vehicles, or typical driving patterns, I guess. And you can see how that compares to gasoline costs for an internal combustion engine. And I was looking at this before. I forget where I got this graphic, but it's based on 8 cents per kilowatt hour electrical rate, which is a little bit low for most Long Island customers. Ours is probably close to twice that, but even still, the charging costs relative to what you'd be paying for in gas is very, very good. This is probably not relevant for tonight's discussion. I put in a little bit of information about the charging stations that we have installed across the community college system with a grant from New York State. and again, this is a way that the government is supporting or encouraging the adoption of electric vehicles by providing grant funding for institutions like community colleges to install charging infrastructure. And it's, it's kind of a workplace charging. So we did this, and now our faculty and students can charge while they're at work, in addition to being able to charge at home. Some photos of what those charging stations look like. Pretty simple setup. You've probably seen some of those out in the world. There's my old Prius charging up on campus. And that's the program that we participated in. So that is pretty much my presentation. I'm not sure where I'm at on time, but this is an opportunity for people out there to ask me or Rosemary our perspective, as owners and drivers of electric vehicles, and you can think about if it's right for you. But I would encourage all of you to at least consider it. My own experience, like I said, has been very positive. I made that transition from plug-in hybrid, almost 20 years ago now, to a full battery electric vehicle, and I would not go back. Will not ever buy an internal combustion vehicle again for a number of reasons. I think for most people, for most use cases, it really is the right choice moving forward. And I think you kind of owe it to yourself to at least evaluate it. Anyway, you can open it up, Jeff.
Yeah, well, thank you very much, Nick. Thank you, Rosemary. I'm going to ask my colleague, John, do you have any questions or comments that were put there in the chat?
Yes.
How do I got to stop sharing this? Sorry.
Okay. How expensive are charging stations for your home? And we don't have any in Port Washington, any public stations. Are there programs we should be pointing our elected officials to for funding?
Yeah, and that's part of what the Drive Electric Long Island Coalition is doing. We're one of our roles is doing outreach with municipalities, and there's a network of folks that we talk to in the different towns and villages across the island to connect them to programs at the state level that would help, like the one that I mentioned that we employed at the college.
And what was that grant that you used for Suffolk Community?
So that was a NYSERDA grant for workplace charging. I forget the name of the exact program, but NYSERDA is a state agency that does a lot of grant work around EVs. They're certainly a good group to talk to. There were federal programs prior to the Trump administration, perhaps, but I think we'll see more of those again. So U.S. Department of Energy is big in the EV world. The first question was cost of charging stations at home, I think. Like I said, I think most electric vehicle manufacturers will provide the charging equipment that you need to charge that car as part of the vehicle purchase. So, I mean, really all that looks like is a cable with a plug on one end that you plug into an electric outlet, and on the other end that plugs into your car. And so I think for most people, what you're going to want to do is to install that 240 volt electrical supply in a convenient location if you don't have it already. So that's a different type of outlet. It's like the kind of outlet that you would plug your electric dryer into. So it's not a regular 120 volt current. It's a 240 volt current. So there was some cost for me to do that. I had to have an electrician come in, but all he's doing is running the wiring and installing the plug essentially there. But the charging apparatus is in the car already. So the intelligence to charge the car, the actual AC to DC converter is built into the car, and the car comes with the cable that you need to plug it in. So
there are also some smart charger incentives that PSCG Long Island offers. These are chargers, I guess, would be in the non-Tesla world, but PSCG offers up to a $500 rebate on a smart charger that through the smart charger allows you to set up to charge later in the evening. And then along with that, PSEG has a rewards program. So if you charge in the late evening hours, you can get a 5 cent per kilowatt hour rebate. So part of what PSEG is trying to do with these incentives is, as we switch from internal combustion engine vehicles to electric vehicles, um, the the impact on the grid will be minimal if people charge primarily at night, which is what makes the most sense anyway. Just plug is the most convenient, because it's not during the peak time. So their incentives is trying to encourage that behavior right from the beginning, so that you just, charge then. And then, you might do some workplace charging or some, off road charging if you're on a trip, but predominantly most of the charging, will be at night. There are also some incentives for municipalities that the DEC offers, that again, the coalition can help step through municipalities. I know that the town of North Hempstead has a RFP out for charging stations for the town that will be a full turnkey operation for whoever bids on that. So there'll be more news coming out of the town as to, I guess, locations and the stuff with that. So that's a possibility for future charging infrastructure up in Port.
Yeah, good point, Rosemary. PSEG Long Island website has really good information on EV charging, both the incentives that she mentioned, and also just general information about the requirements for typical vehicles. So yeah,
The other thing
also Drive Electric Long Island. Our website has good information in there as well.
Yeah, we have a lot of resources on the website to go and get more information. Another incentive that's just a new program that's coming out from PSEG is something that's called a make ready cost. So for institutions, companies, municipalities putting in infrastructure, there have been incentives for the charging stations, but there's been costs associated with getting the site ready for that charging station. So it's running the cabling and the like. And there's a recognition that that can be a significant cost. So statewide, there are these new programs that these expenses are going to be funded either partially or totally, depending on the location, through ratepayer type funding. So there's some significant incentives to address some of the costs associated with that. And as we expand the infrastructure, then we're addressing what is generally called range anxiety. A lot of people feel that they don't want to drive the electric vehicles because they're afraid they might not be able to charge it, even though they don't realize, as Nick mentioned, that most of the time you're just going to plug it in at night, just like you do with your iPhone. But for longer trips or for the like, having that infrastructure. From our perspective, having the infrastructure also makes people think about electric vehicles. Like, oh, we have a charging station there. Maybe I can go look at, an electric vehicle. So it makes it a little bit more visible around the island as well.
Okay.
The other thing that, Nick, I don't think you spent as much, maybe you could spend a couple of minutes on, is the difference between a regular hybrid vehicle, a plug-in hybrid, and a full battery electric vehicle.
Yeah, so I mean, I think what those different categories represent is kind of the evolution of the industry. From my perspective, I think hybrid vehicles are sort of the bridge technology to get us from the internal combustion engine to an electric vehicle. They were sold, I think, designed, manufactured, and sold at a time when battery electric vehicles weren't really there yet, because the battery technology hadn't evolved sufficiently. When I bought my first Prius in 2002, there was no Tesla, there was no manufacturer that was making a vehicle that was really capable of meeting most people's driving needs, certainly not mine, but the hybrid kind of gave you the environmental benefit and the fuel efficiency benefit. And But what it didn't give you really are some of the other advantages that battery electric vehicle gives you in terms of reduced mechanical complexity that I talked about. I mean, a hybrid really is a combination of two power plants. You've got an electric motor and a battery, plus you've got an internal combustion engine, and those are coupled together in a way that they can benefit one another. But there's a lot going on in a hybrid vehicle. The plug-in hybrid was kind of the next step in that evolutionary process, where you were getting a bigger battery, and by plugging it in, you were extending your electric driving range. And so you were getting additional fuel efficiency, and you're getting additional range. And so it was starting to kind of migrate to some of the advantages of the battery electric vehicle that we see today. But you still, again, have two power plants. So it's kind of, taken that evolutionary period. I think, the industry had to mature. There had to be this kind of evolution in the battery chemistry, and a reduction in the manufacturing costs, to the point where most people could afford it and it would meet their daily driving needs. And I think, that's why I'm saying I think now is really the best time that there's ever been that, to buy an electric vehicle, because the costs have come down, the technology has improved to the point where, for most people, I think, this is just my personal opinion, but for most people, there is an full electric vehicle solution that will probably meet their needs and be within their driving budget if you're considering, full cost of ownership. It's at least comparative to, the performance and the economics of an internal combustion engine vehicle. The hybrid, albeit a standard hybrid or a plug-in hybrid vehicle, is kind of that sort of in between for people who are not ready to take that leap. But from my perspective, most people can take that leap now. It's just that kind of paradigm shift that you've got to get past.
Okay, we have some questions about range. How many miles can a car go without recharging? Do you ever worry about range on long distance travel? And on a trip to get a full charge, how long would you expect that to take, and how much would it cost?
Okay, well, I'll speak to my own experience. Again, I drive a Tesla Model 3, which is, it's a relatively expensive car, but I think it's comparable. If you look at total cost of ownership, it's comparable to, a internal combustion engine vehicle of similar value, I think, in the marketplace. My car has 325 miles of range on a fully charged battery. And for my daily driving purposes, that's more than sufficient. I mean, I'd probably drive under 50 miles on a normal day. So again, if I start in the morning with a full charge of 325 miles, I'm coming home, I've only used 50 miles. I'm plugging it in if I want to. I don't need to, but I generally will plug it in. And in the morning, I've got 325 miles. Again, I've got a fresh start there. The other question was, do I think about it on a long trip? I mean, if I'm traveling somewhere that's further than 325 miles, it's a consideration. But, again, it's kind of like most people, I think, if you're going on a long trip, you kind of factor in you're going to need to pull off and get some gas somewhere along the way. My car and most electric vehicles have the built-in capability to tell you, that what your state of charge is at any point. Just like on your phone, you've got a graphic that tells you, how many miles you have left. And the car itself will tell you what your options are on the route that you're navigating, where you're going to need to recharge. And so that part of it couldn't be simpler, really. I mean, the car kind of tells you what you need to know.
And it knows where the stations are.
Sure, it's gonna incorporate that into your route, and it'll tell you along your route optimally, and more you're gonna see, at least on major roadways. I think the only concern, I've never really had a situation where I had to worry about it. I think, if you're traveling in very remote areas, perhaps long distances, out west, perhaps, it might become a challenge. But I think certainly for our region, it shouldn't be an issue.
And third question was about cost.
Cost to charge, yeah. So I did put up one chart there. I know it went very quickly, but it gave you, I think, a general sense of the relative cost of charging electric costs versus what it's going to cost you to fuel up your car with gas. So when I'm charging on the road, again, my experience, I use the Tesla supercharger network, which is very expansive and readily available. My typical charging costs, the most I've ever paid at a supercharger, if I pulled up and had, maybe under 100 miles left on the battery, and I wanted to get a full charge, between $10 and $12 would be my cost. And that would be, probably take between 20 and 30 minutes to get that full charge at a supercharger. So
That kind of electricity is subject usually to demand charges by the utility, which increases the cost. So it's still cheaper than equivalent to gas, but when there's a lot of electricity being delivered in a short period of time, there's more infrastructure that's required to provide that electricity, so that those demand charges get worked into the cost in that situation. But again, most of the time, you'd be charging overnight at home and not subject to that.
I think what you're going to see in the future is, as the adoption rate for electric vehicles increases, the charging infrastructure is going to become a more competitive environment. Again, as a Tesla driver, Tesla has their own ecosystem, so they provide charging infrastructure for their vehicle owners and their fleet, and their charging rates are very inexpensive. They really are recovering their cost of operation. So it varies depending on, what the electrical rates are in that region. But again, I think you're going to see that it's well less than what you would be paying for an equivalent, in internal combustion engine fuel. But I think in the future, other manufacturers, as the charging networks become independent and cost competitive, I think you're going to see that, much like gasoline, right? You wouldn't go to a gas station that was charging $10 a gallon. You'd go to the other one that would charge, a quarter of that. There's going to be a competitive dynamic on charging infrastructure that hasn't really materialized yet, but will. Sorry, Rosemary, what were you going to say?
Just some of the range in some of the other models with the other manufacturers.
Yeah, so this is one of the you do see more expensive electric vehicles coming into the marketplace that have really significant range, right? The Lucid Air, I think, is a recent one that was announced that has over a 400-mile range. But that's an expensive car. It's an $80,000+ car. I think, there's that variation in the market. Some of the less expensive vehicles, electric vehicles that are available, the biggest cost factor for an electric vehicle is the battery itself. And so at the lower end of the vehicle cost curve, you're going to see cars that have less range. And so, if you don't need a car that has a 350 to 400-mile range, you can buy a less expensive electric vehicle. But there is a sort of relationship between range and vehicle cost.
The last question is about why you chose the vehicle that you did. Why Tesla or why the others?
I think right now Tesla is really dominating the electric vehicle sector. I mean, they are far and away the best seller in the EV market. And there's a reason for that, because they offer a really, I think, good value. I'm trying to be objective here, but they do offer a very good value, a good, I think, balance between cost and performance and range. Efficiency is part of that. So they have a good vehicle in the market, and their stock price and their sales are reflecting that. Their demand is a function of the fact that they really are putting out the best EV on the market right now. But there are competitors coming, certainly, and I think other vehicle manufacturers are looking at Tesla's success and are trying to emulate that, and there will be competition. But I think right now, if you're asking my personal opinion, if you can afford a Tesla, and I think they're more affordable than most people realize. There is a range. I have a Tesla Model 3, which is their lowest cost vehicle, and it's comparable with a median class sedan in the internal combustion engine world, and it's a fantastic car. And it's something that I had aspired to for quite a while. And the first vehicles that Tesla announced, the Model S and the Model X, were well out of my price range, but the Model 3 was designed as their low cost entry, and it was within my vehicle replacement budget. And I think I had already kind of gotten past the other concerns about making the switch to a full EV. But it was really just that purchase cost that was holding me back. And once Tesla came out with the Model 3 and I could afford it, I was all in, and really regretted it all.
What we saw on Long Island in 2019 and in more so even in 2020 was a real shift towards the Tesla. And a lot of that is documented through studies by Sierra Club, some work we've done locally here in just going out and checking dealers alone. Is there didn't seem to be the same user experience going into the dealer as you got in when you go in a Tesla that was all in on selling electric vehicles. I myself, as I went searching for either an electric vehicle, full battery, or a plug-in hybrid, found experiences of dealers not having inventory in stock, not having good lease prices, dealers not knowing the difference between the product. Some dealers, even when I told them who I was, chairing an education outreach committee, trying to cross-sell me off to the hybrid vehicle, not a plug-in. So I'm really excited about the new administration and already the turn that's happening with GM committing to a full electric. I think that they got mixed signals with the previous administration and didn't know if they were going to kind of be forced to go this way with the mileage standards. And now I think they're seeing that this is going this way, and seeing how successful Tesla has been. So on Long Island, in 2018, we were seeing more plug-in hybrids than full electric vehicles. In 2019, that shifted, and it was all growth, from Tesla. And 2020, everything was, affected by COVID. So it'll be interesting to see this year as the other manufacturers are coming out with a lot more models, also crossover, vehicles, SUV models, where the public wants those type of models, as well, which is some of the reasons in them not going electric. That I think there's going to be an interesting year, this year.
So it looked like, let's see, Mary, looked like you had raised your hand there. You can unmute yourself if you like to ask a question directly. Not sure if she's there or not.
No, I'm here. I just, in January, it's more a comment, January 15th in the New York Times, they had a very nice article about electric versus gas powered cars. They seemed to check out all models, and they compared the monthly cost of electric to gas, and also their emissions rate. They graphed too, and as the speaker said, I guess yes, they were lower cost and lower emissions than 80% of the other cars, you know. So it was interesting. It was a good article. Just a comment. Thank you.
Yeah, thank you, Mary. So you just mentioned, Rosemary, the announcement by GM in the last several weeks. What do you guys think in terms of like how much? I know the industry was kind of a bit shocked that they made that big announcement. What kind of effect do you think that's going to have? Is that really going to accelerate things? Is that, you know, I know we're seeing things over in Europe that are moving pretty quickly in that direction. What are your
And in
predictions
China,
about that?
a lot I understand is being driven by what's happening in China and the acceleration. What do you think,
Yeah.
Nick?
I think all the major car manufacturers see the handwriting on the wall. I think they recognize fundamentally that the EVs are the future and they're trying to get there. I think they're going to have a challenge in that their business model is predicated on selling internal combustion engine vehicles, and they've got to make a switch in terms of their production cycle. They've got to basically shoot themselves in the foot in order to make this change. They've got to stop selling, you know, their bread and butter vehicles and move to electric vehicles. So it's going to be a difficult transition. I think there's going to be a lot of competition from startups, from companies that we haven't even heard of. Like Rosemary said, there's a lot of Chinese manufacturers coming online. You know, that is another, you know, competitive dynamic that they've got to contend with. It's a tough thing for GM to make the pivot, and yet the fact that they're doing it shows you that they recognize that they need to do it, because you know, Europe has already announced that, you know, limits. The state of California has announced. I think New York State is either close to, or I mean, they've set targets for phasing out internal combustion engine vehicles. So it's going to happen. It's just a question of how quickly. I mean, this is kind of the goal of the Drive Electric Long Island Coalition, is to accelerate the adoption of electric vehicles. We kind of know that it's coming. It's just a question of how quickly do we get there. Just like renewable energy, you know, solar and wind, they're coming. It's just a question of how quickly does it occur, and you know, how much damage do we do in the interim. But you know, in terms of the industry itself, it's a tricky thing for these traditional automakers to make that pivot.
And it's tricky for the dealers as well, because oftentimes their business plan is on service. And
Right.
so if they switch over to cars, like the plug-in hybrids have, as Nick said, both power plants. You know, they got the internal combustion engine and the electric engine. But when it switches over to full electric, there's a lot less parts. You don't need, there's no oil changes, there's no spark plugs, there's no, you know, you don't change your brakes as much. So you know, having them get excited about moving that way, it's a challenge.